Mathematical practice number 7. Look for and make use of structure. The standards for mathematical practice, often called the mathematical practices or the math practices, can be found on pages 48 through 50 of the College and Career Readiness Standards for Adult Education. These practices describe behaviors and thought processes that support mathematical thinking and reasoning. So that students have experience with all 8 practices, it's the role of teachers to encourage the practices and incorporate them into activities. This webcast will highlight Mathematical Practice 7, Look for and make use of structure. So, to begin investigating Mathematical Practice number 7, let's start at the library. I'm Amy, and I'm here with Virginia, the librarian. I asked Virginia to help me make sense of Mathematical Practice number 7, Look for and make use of structure. So, Virginia, how does this library make use of structure?
Is that we follow a decimal system, the Dewey Decimal System. It's a system that's about 100 years old,
Okay.
roughly, and it starts at 0 and ends with 999.999 as far as you can take that 9 out. And every number means something.
So, trying to make sense of this in terms of how we can use it for math, I'm thinking that if you just had a stack of books, then it would be really inefficient to try to just find a book out of that stack. But if you have the structure that you understand and you know how it works, then you can use that structure to find all kinds of books.
Exactly. There has to be some structure in the library to put the books together. Even the Library of Congress has an alphanumeric code. Every library does.
So, and I would even say then that it has to be something that everyone understands. That it can't just be that you have one structure and then someone else has a different structure.
It cannot be random.
Yeah, because it's a system that everyone has to use.
You have to be able to understand it. I've gone to libraries all over the world, and once you learn the system, you're in.
Even in a new situation, you would still be able to draw on what you know about how the library is structured, and you can still find the book that you want. So when working with math, even if it's a new question that you've never seen before, you could still draw on what you know about how things are connected and how the pieces fit together. Maybe how the operations or the equal sign, how the number relationships fit together. And you can use that to solve problems.
Absolutely, and you know the thing. There's a structure to everything. It's kind of like universal, you know? Everything has a structure.
Thank you very much for taking the time to have this conversation about, to help me understand Mathematical Practice number 7.
My pleasure.
Now that you've got a sense of the meaning of this practice, let's look more deeply into what it means to look for and make use of structure. I'll highlight 3 features of this mathematical practice, as well as example activities at different levels that work with each feature. All of the math content examples that I share can be found in the College and Career Readiness Standards for Adult Education. To encourage learners to look closely to find a pattern, structure, or properties, you could ask them, how are the quantities or images related to each other? Do you see a pattern? For example, at a lower level, when discussing the commutative property, you could ask students to share examples showing that the commutative property applies to addition and multiplication and does not apply to subtraction and division. As students create their own examples of the commutative property, they will gain a better sense of the structure that property brings to math. You could also ask students to draw sketches or use objects to illustrate the equations that they write. At a higher level, students can apply their understanding of addition and subtraction and the number line to find patterns that will help them combine positive and negative integers. When they understand the structure of the number line, students will find it to be a useful tool with familiar as well as new concepts. By encouraging learners to look closely to find a pattern, structure, or properties, you'll see them explain their reasoning more skillfully because it will be grounded in mathematical principles. Now let's continue to the second feature. To encourage learners to see complicated things as composed of other objects, you could ask them, "What kind of problem is this? How do you know? And how can you use that to get started?" For example, at a lower level, students could solve simple addition and subtraction equations in which one of the numbers has been replaced by a question mark by using their knowledge of the operation signs, the equal sign, and the number values. This exercise will reinforce students' understanding of the structure of equations as well as the meaning of the equal sign. They will see that, though some of the equations may look complicated at first, they are actually composed of familiar objects. At a higher level, students could use their understanding of finding area to solve surface area problems, since surface area is a combination of the areas of each of the faces of a three-dimensional object. Students can look for and make use of structure as they approach this complicated problem as composed of more familiar two-dimensional areas. By encouraging learners to see complicated things as composed of other objects, you'll find that you'll see them compose and decompose numbers and relationships, as well as pausing to find structure before jumping too quickly into computation. The third feature of looking for and making use of structure is encouraging learners to draw on what they know to solve a problem. To encourage this, you could ask, "How is this like a problem that you know how to solve?" For example, at a lower level, students could find the sum of 3x and 5x to be 8x because they know that 3 chairs and 5 chairs combine to make 8 chairs. At a higher level, students could apply the Pythagorean theorem to find the distance between 2 points on the coordinate grid because they have practiced using the Pythagorean theorem when working with right triangles in a geometry context. By encouraging learners to draw on what they know to solve a problem, you'll see them thinking more flexibly and being more willing to try a problem rather than being stuck. Each of the previous examples illustrates how students could look for and make use of structure. Now let's watch these high school students look for and make use of structure as they work with transformations.
Good morning, ladies and gentlemen. We have a really challenging exercise. So you're going to get 6 of these shape cards. The next thing you're going to get is word cards, and these have arrows on them telling you where to go. What you want to try to do is connect all of these shapes using the arrow and word cards. Students were given all these cards, and their job was to connect them in the most complete way possible. Students actually collaborate with each other, and I start to take a step back and watch and facilitate at times, but mostly let them work with a partner.
Okay, so we got those two reflected over X, these two 180, these two Y, those two clockwise. So with these, do these two do anything together?
How else could you make it?
Go ahead.
No, the lesson, it was tough the first time, like trying to figure out the pieces to go together. But like once you do the work and put it out, like it got easier.
So how y'all got C with F?
Because once you, like, what's C at? So, and what F? See, once you like rotate it around the origin, it's gonna end up in this place.
And if you
Get
do
your own
it
paper.
the other way, it's gonna be that way too.
Hold on, because I have to be
Joy.
I have it like this.
Alright, now rotate it around
Hold on, no. What I had this for? C,
C
huh?
and F,
I had
yeah.
this for C.
Alright.
Now rotate. Now put your pen on right there in the center and rotate it 3 times.
Which way?
I mean, 2
clockwise or counterclockwise?
Anyway,
Anyway.
it's gonna end up in the same place.
Now put C. Now put F on top of. Look at. Now pick it up and put F under it.
It don't look like
It's not the
it.
same.
Well, let me see.
But if you do it with B, okay.
It was the
It
same
should be.
flowers.
Alright,
Rotate.
I rotated. Go by 90 degrees. Alright, that's 90. It's not the same.
Ours was different.
We started talking with other classmates, and we were seeing like how they got different matches from us, and we were trying to figure out like, well, are their matches right and our matches wrong? And we was just going back and forth trying to figure out who was right and who was wrong to see if we had the right match. We did
The
this
same way. And I
F
was.
is, this one is lower, I mean higher than F.
That's
F
what
is
it
lower
is.
than
ours.
so it don't match up with F, match up with B.
Yeah, they did.
Rotated 180 around the origin. Cause look, when I put it with B, it's gonna match up. It should match up. We were right and they were right, and there were 2 different answers.
How did the students in the video demonstrate that they were looking for and making use of structure? Did you see them looking closely to find a pattern, structure, or properties? Did you see them widening their perspectives to see complicated things as composed of other objects? Did you see them drawing on what they know to solve a problem? All 3 aspects may or may not have been demonstrated in this particular video. What other mathematical practices did you observe? Feel free to pause the webcast while you think about or discuss these questions. The students in the video were asked to connect shape cards with word cards. Connecting shape cards with word cards is an activity that would be meaningful and engaging at all math levels. You could adapt the content of the cards and the activity instructions to fit your own context. In conclusion, I want to share this poster that summarizes mathematical practice number 7. The next slide shows the link where you can download the poster to print and post in your class, as well as links to all of the other resources used in this webcast. How will you encourage students to look for and make use of structure?